Hello, everybody. Welcome to How Green is My OpenTelemetry Collector. We're super excited to have you join us here today. This is our first time speaking together, so we're super stoked. Woo! Yay! I love the energy in the room considering how late in the day it is. Okay, so let's get started. My name is Adriana Villela. I am a CNCF ambassador, blogger, podcaster, and one of the maintainers of the OTel end user SIG. By day, I'm a principal developer advocate at Dynatrace, and I spend most of my time with OTel and observability, and by night, I like to climb walls, and I love checking out local bouldering gyms in the various cities that I visit. I also love capybaras because honestly, they just make me happy.
Yeah, I'm Nancy, and I'm super excited to be doing my first talk with Adriana. I'm a CNCF ambassador. I am also Tag Environment Sustainability Co-Chair Advocacy. And I've worked as a DevOps engineer, CNCF DevOps engineer, then open source contributions, also worked as developer advocate. And in my free time, I love cats, and I love to travel. So yes, let's get started. Global warming is real, and I think like each one of us in the room agrees with this. With the erratic weather conditions and rising sea levels, we all know that it's for real. Let's see some facts. So what country is moving its capital city due to climate change concerns? So, and that's kind of concerning. So Indonesia is moving from its capital city, Jakarta, to a new capital city due to climate changes, rising sea levels.
Next question is, what percentage of global carbon emissions is the IT sector responsible for? And the answer is 2% of global emissions. Now, we expect that to hold at around 1 to 2% in the next several years, but then expect it to rise up to 12% by 2040, which is completely staggering.
That's a huge number, and that means we need to adopt more greener practices. And with that, we have a fact that according to Essentials 2020 report, how much can public cloud migration reduce carbon emissions? And the number is 84%, so that's huge.
Now, given all of the carbon emissions that the IT sector is responsible for, one would assume then that OpenTelemetry is part of the problem as far as contributing to those carbon emissions. After all, we are emitting telemetry, and that uses up CPU, memory, and then also, as much as our applications are emitting telemetry, we also have applications that are ingesting the telemetry. So whether it is your SaaS vendor sitting on public cloud somewhere, or maybe you've got a homegrown solution sitting on public cloud or private cloud. So all these things add up. So the question is, how can we make OTel greener?
And how about we start with OTel Collector? But before we move with that, I just want to mention that to take an action, we first need to measure something, and then we need to experiment, like how can we make our applications greener, what practices we can adopt, and then we can basically mitigate. So as you can see a diagram over here, so this is cast of characters. This is something which we are going to talk more in detail in today's talk. So we have a Kubernetes-based observability setup. We have Kepler. We have application deployed in Kubernetes. We have OTel Collector. We have Prometheus stack and observability backend. So Kepler is going to collect the energy consumption metrics from OTel Collector and application. And then we have OTel Collector, which is going to ingest the application telemetry and infrastructure telemetry and Kepler metrics to the observability backend. We also have Prometheus stack, where in Prometheus basically store the metrics, and Grafana is used for observability. But if you have your own observability backend which supports the Prometheus metrics, because Kepler is basically exporting the metrics in Prometheus metric format, so you can basically use the observability backend as well. Your own observability backend.
Okay, so I'm just going to take a step back here. So, oopsie. So as Nancy mentioned, we are using the OTel operator as part of our setup. Now, the OTel operator, in a nutshell, is a Kubernetes operator that allows us to do all sorts of wonderful things, including the management and configuration of our OTel collector. And our OTel collector, for a quick refresher, is used to ingest data from various sources, application and infrastructure. Then it'll do some processing, whether it's adding, removing attributes, obfuscating data, etc. We also have our connectors, our extensions, and then we send our data somewhere. And then, as I said, we are using the OTel operator, and because Kepler emits those Prometheus metrics, we're leveraging a component of the OTel operator called the target allocator, which also does some wonderful things, but one of the things that we're taking advantage of is the target allocator's Prometheus CR discovery. And specifically, for those who have run the Prometheus operator in the past, that includes the ones that we care about are the pod monitor and the service monitor. So these can be installed as part of the Prometheus operator, or in the case of you're using a Prometheus list setup, you can basically just install the pod monitor and the service monitor separately, just the CRs themselves, and the target allocator will play nice with them. Now, the target allocator, what it does is it discovers Prometheus operator CRs, so it goes into the Kubernetes cluster and says, okay, are there any CRs here that I need to know about? And then it'll add the jobs to the target allocator scrape configuration, and then it will in turn say, hey, OTel collectors, please add those jobs to your scrape configuration. Specifically, that's done in the OTel collector's Prometheus receiver. So that is our target allocator, OTel collector, OTel operator overview.
Awesome. So I just want to ask, like, do you folks know about Kepler? Maybe if anyone can raise hands. I see Nikki. We are in the same tag environment, sustainability. So there are a few hands. So Kepler is short for Kubernetes-based efficient power level exporter. It's a CNCF project, so it's open source. You can contribute as well. You can check this out on GitHub. So what exactly it does is it monitors and optimizes the energy consumption in Kubernetes environment. And it exports the Prometheus metrics, which we discussed earlier. So what exactly it uses behind the hood is it's using the eBPF technology, which basically collect the data like CPU performance counters and Linux kernel trace points. So it collects the data from that, and then that data is fed into ML models, which basically estimate the energy consumption of your Kubernetes components like pods and nodes. So that's Kepler, and this is the architecture, and you can also, so there is a QR code, you can scan it, and you can know more about Kepler, the website. You can check more about Kepler from the website. So yes, now let's install the Kepler. So for installing the Kepler, you need Kubernetes cluster. You also need Helm. You can use the manifest, but Helm is easier, so in our demo, we are going to use Helm. Then you need Prometheus or any backend that supports the Prometheus metrics, because Kepler is going to export the Prometheus metrics. And then you need OpenTelemetry operator. In our case, we are going to use OpenTelemetry collector to scrape the metrics. So yes, so this is an optional step, which is installing the Prometheus stack. It's optional, but before moving ahead, like there's a scan, you can scan the QR code. We have made the GitHub repo public. So if you want to try out the demo, which we are going to talk about today, so you can scan the QR code. So first, we are installing the Prometheus stack. It's an optional step. If you have your own observability backend, so you can go ahead with that. So this is something which we are installing the Prometheus stack, and then we install Kepler. So with Helm, we basically add Kepler. We also install Kepler in the namespace called Kepler. We enable the service monitor, and then we also enable process metrics, which is basically going to give the detailed metrics for your processes in a container. So you can enable process metrics if you want to get extra information. Then we are installing the Kepler service monitor. So here we are giving the Prometheus scrape configurations. And over here, we are basically dropping some of the metrics. So you can see that if you want to drop some metrics. So we are dropping the metrics because it can be an overload. So that's why we are dropping the metrics. Then we are installing the Grafana Kepler dashboard. Again, it's optional if you have your own observability. So, if you're using any observability backend, so you can just go ahead with that. So in the first step, we are basically waiting for the port to get up so that Prometheus is installed. And then we are basically getting the Grafana pod namespace, and then we are basically installing the dashboard. So we have a JSON and Grafana dashboard JSON, and we are installing that. Then we are installing the OTel operator. We are installing the cert manager. We are waiting for it to get installed. And then finally, we are installing the OpenTelemetry operator.
All right, so the OpenTelemetry operator. So basically what we're doing today is we're tuning our collector, and in order to do that, we need to do some configuration of our collector. Because we're using the OTel operator to do our collector management, we are leveraging a custom resource of the operator called OpenTelemetry Collector. So I'm going to go through the main configuration points of the OTel Collector CR, just the main highlights. Now, if you want to see the full source code for the OTel Collector CR, you can scan the QR code on your screen. So first of all, because we are using the target allocator, it means that we have to enable it first, because by default, it is disabled. And also because we're doing the Prometheus CR discovery, we need to enable that as well. So we do that here. Next, we are ingesting data. Now, if you recall from our diagram from earlier, we want to ingest some application telemetry because we are going to be sending some application telemetry to our collector so we can get a feel for how much energy it is expending. So we are using the OTLP receiver, but as well, because we are receiving those Kepler metrics which come in Prometheus format, we need to use the Prometheus receiver. Now, in addition to that, we want to ingest some Kubernetes telemetry. So we are using the K8s cluster receiver, which gives us cluster level telemetry thanks to the Kubernetes API server. And then we are using also the kubelet stats receiver, which ingests telemetry at the kubelet level for your nodes, your pods, your containers, your volumes, again, courtesy of the Kubernetes API server. Next, we're going to move on to our processors. So there are a few things going on here. First of all, this processor here is the transform processor. And what we're doing here, all we're doing here is basically replacing the names of the metrics that we receive from Kepler that come in the Prometheus naming structure format. So we're moving basically from this underscore notation to the standard for OpenTelemetry, which uses dot notation. So that's all we're doing here. In addition, we're using the K8s attribute processor, which is enriching our Kubernetes, enriching our telemetry with additional data about our Kubernetes cluster. And then you'll notice here we have a second K8s attributes processor. And the reason why we have two is because we actually have two metrics pipelines, which I'll get to in a second. But in this one, again, we're enriching our telemetry data with some more Kubernetes metadata, but we're just adding we're just enriching a little bit less. And then finally, we have the resource processor, where we're essentially adding our cluster name to our telemetry data. Now, I'm going to skip over the exporters because in this example, we're going to be exporting to an observability backend. And if folks here, we're assuming here that folks here are pretty familiar with OpenTelemetry and have done that sort of thing before. However, if you scan the QR code on your screen, as I said, it's the full code example that shows how that's done. So we're going to skip over to the service definition and look at the pipelines in detail. And in particular, you'll notice that we have 4 pipelines. I've grouped them into 2. So we have our traces, metrics, and logs grouping, and these are our application pipeline. And then we also have our second pipeline, which is basically our Kepler or Kubernetes pipeline. And here we're ingesting our data from our Kubernetes cluster. We're ingesting our Prometheus data. This is where we're ingesting our Kepler data. And the reason why we have 2 separate sets of pipelines is we don't want to pollute the application pipeline with our Kepler infrastructure pipeline. So that's why we've got that. Now, that's all well and good. So we figured out how to configure our OTel collector. We figured out how to install Kepler, Prometheus stack, and the OTel operator. But okay, what are we doing with this? So we decided that, hey, let us run some experiments to figure out, like, what are we tuning in the collector, right, to see if we can make it greener. So we thought of doing a couple of things. First of all, as I mentioned, we've got two sets of pipelines, right, our application pipeline and then our Kepler pipeline. So what if we took our single collector file and split it into two? So then we have one collector instance basically for defining our application pipeline, a second collector instance for defining just our Kepler pipeline. And then the second test that I thought would be kind of cool, well, we know that it's best practice to build your own collector distribution. So what if instead of using contrib, because I'm using contrib as my baseline for all of these, what if instead of using contrib, I built a custom collector distribution using just the components that are necessary to do this. So I am not going to use any of the processors and receivers and exporters that aren't required, that I haven't configured in my collector configuration, and we'll see if we see any improvements. Now, now that we have our tests, these are the things that we measured. Now, Kepler exports a metric called Kepler container joules total. So it gives us the energy output of our, in our case, our OTel collector. That's what we want to measure. We convert that to kilowatt hours. And then the other thing that we want to do is do a ratio of the energy consumption. So we compare our new thing that we've changed against our baseline, which is our unit, collector, contrib image with like the single pipeline, right? And the idea here is if the ratio is positive, it means that we're seeing an improvement. If the ratio is negative, then it means we are not seeing an improvement, it's actually worse. The other two things that we want to measure are actually metrics that are emitted by the OTel collector itself, because it has the ability to do that. And we are looking at memory consumption. So these are the two memory consumption metrics that we're looking at. And the reason why we want to look at that is because our applications are constantly allocating and deallocating memory. And every time you're doing stuff like that, that uses up energy. So let's see if we see an improvement. So I ran a bunch of tests, and here is one of the results. So basically, the green line up top shows our unit collector, and then the white and yellow lines are our two separate collectors. And as you can see, individually, these collectors use up less energy than the single collector. Awesome. But keep in mind, these are two collectors, not one. So we need to look at the data of the two collectors as a single thing. And when we combine them, we see a difference. So the blue line represents our two collectors combined, and the white line represents our single collector. And that makes sense because we are essentially running two replica sets of the collector. So no huge surprise. The next thing that we're looking at is the ratio, and as you can see, it's a negative number, which we said means that it's performing worse, so not so great on the energy consumption. And then the memory consumption. Remember, these are the two memory metrics that we were looking at, and as you can see from the lines, they look about the same, so that's kind of interesting. We don't see anything major on the memory consumption, but we definitely see on the overall power output from Kepler. Now, the next test that we ran was for building your custom collector distribution. So the blue line represents our custom distro, and our white line represents our baseline contrib. And it looks like, in general, the blue line is faring a little bit better than our collector contrib image. And if we look at our ratio, yeah, it's doing a little bit better. It's a positive number, so good things happening. And if we look at the memory consumption, so the white line represents our contrib collector, the blue line represents our custom collector, and we can see that the custom collector uses less memory than our contrib collector. So that's pretty cool to actually see in action. So based on all this stuff, what have we learned? Well, first of all, it's important to try different things, right? Look at all the different ways that you can tune your collector, or it can be something else, right? It doesn't just have to be your collector. Any application that you're running in Kubernetes, tune your pods, figure out, see different ways that you can change things up. The other thing that's super important when you're running these kinds of tests is don't change too many things at the same time. So in both cases, I had a baseline, which was my single contrib collector with the single pipeline, and in each case, I changed one thing. One, I split it up into 2 pipelines, but still kept the same base collector image. In the other case, we changed up the collector image. So that way you can keep track of things, and so when you're testing things out, you know, okay, I changed this, so this had an impact, or this did not have an impact. Finally, don't rely on just one test, because one test will not tell you the full picture. For example, in the OCB test where I built the custom collector, the first few tests showed the energy output of the custom collector was lower than that of the contrib collector. However, subsequent tests showed that it was actually worse, which is quite interesting. So you can't rely on just one test. I would also recommend testing it on the same infrastructure. So if you're going to test it, keep testing it on the same Kubernetes cluster in the same region, the same cloud provider, because again, all these things are like different variables. The other interesting thing to note is on the collector distro test, one thing that was consistent across the board is that the contrib collector consistently used up more memory than our custom collector image. So the other thing is tuning is never done, just like software is never done. I mean, you can always find things to optimize. And also be prepared. What Nancy and I learned is that there is a lot of stuff to learn for this. We had to learn Kepler. We had to become a little bit more familiar with the OTel operator. We had to figure out like gnarly configurations of the OTel collector that I honestly didn't even know existed. You have to be semi-proficient with Prometheus and semi-proficient with dashboarding in whatever environment you choose, whether it's Grafana or your favorite observability backend. So there is a learning curve. And also shout out to my coworker, Henrik Rexed, because he helped us out a lot with the elements for this talk. So without him, we would have been royally screwed. So he helped. Also, don't expect a quick fix. In the same sense that we can't say, hey, I'm using Jenkins, therefore I'm DevOps. You can't say, I'm using Kepler, therefore I am super optimized.
Wow, that's been amazing. We talked a lot about the experimentation and like the measure part, so let's talk about now what. So we're going to take it to the next level. The first step was about measuring and doing the experimentation. And you're going to learn a lot of new things. So there's a huge learning curve, which Adriana already mentioned. So one thing is conducting green reviews. And this is something which we do in our tag environment sustainability as well. So if you want to take part in it, you can look for the green reviews Slack channel, Slack in the CNCF channel. So what exactly green reviews does is it measures the carbon footprints for the CNCF projects. So then you can use Kube Green to spin down the unused Kubernetes pods, and there's a QR code as well, so you can read more about it. You can use Kube Cost to monitor and reduce the Kubernetes spend. So by reducing the carbon emissions, you're also saving the infrastructure cost. You can also use build packs for greener container builds. You can choose greener data centers. Sweden is one of the greenest data centers, so we should definitely, fun fact, definitely we should
run all your
workloads
in Sweden.
Yes, and if your backend supports metrics, consider ditching Kube Prometheus stack. I mean, we can use the existing stack. So this is something which I picked up from the Tag Environment Sustainability website, and you can learn more about it. There are different toolings which you can use, which can help you optimize the carbon emissions. Then we conducted interviews with the experts. So Henrik has helped us a lot, and this is something which he says, that you need measurements, which we've been saying since the beginning. You need to first have tools and measure the energy in your solutions. You need to reduce the code that generates heavy CPU cycles and memory allocation. You can install some tools which can measure the CPU cycles and the memory allocation. For example, gprofiler is one of them which does this. You can also identify the working hours of environment to turn off application during night hours, and you definitely save the infrastructure cost as well over here. Then we did it with Christina. She is, again, one of the chair of Tag Environment Sustainability. She's an amazing engineer. She says that clean up unused services and regularly audit everything that is running, Also scale down if there is too much unused capacity. So these are some of the facts which we have picked up, but there's a huge interview which we taken, and it's on GitHub, so you can basically scan the GitHub repo which you scanned earlier. You're going to find the interview in detail over there. Then we have Yushin Pharma, and she's one of the expert in machine learning. She says that GPU waste is your biggest leak, and we should be concerned about this because AI is something which each one of us is going to use. So fix the pipeline. Most teams use only 20 to 30% of their GPUs. This is her observation. AI-first infra from all angles with efficiency down to agentic job level at interference time compute. And future breakthroughs in AGI needs to optimize the access, both software and hardware, and that's where the magic happens. And the last one is Dave and Elena. They are from the PTC group. They say that reducing carbon footprints is not a sunk cost, but actually helps company reduce expenses.
And so we're going to leave you off with some handy resources. We got a link to the Kepler project. If you want to check out the full example that we talked about today, we have a public GitHub repo. You can scan the QR code for that. There is the link to the cloud sustainability landscape diagram that we included, that we showed you earlier. Check out my coworker Henrik's video called Go Green with Kubernetes. He dives super deep into that. Also, because we had the adventure of building our own custom collector distribution for the first time. I documented some of the things that I learned and the gotchas that I encountered personally. So if you're ever doing that, check that out. And then finally, check out environmental sustainability on CNCF Slack. And we're going to end off with some shameless self-promotions. So as I mentioned, I do have a podcast. It's called Geeking Out. My daughter helps me edit it. She's 16. She also designed the logo, which includes capybaras, and I have stickers if anyone's interested. I've had really cool guests on, including Kelsey Hightower, Charity Majors, Liz Fong-Jones, Hazel Weekly, who's sitting at the front, yay! Nancy's been on as well. And if anyone is new to observability with OpenTelemetry, I do have an O'Reilly video course on that topic. Also, OTel Community Day is happening in Denver, Colorado in the States at the end of June. So if anyone is coming to Open Source Summit, that'll be part of that week, so do check it out.
Oh, damn, I can't skip this. So learning from Adriana. So I basically founded Women in Cloud Native Community in December 2022. We also had a gathering this morning, and fun fact, 90% of people were the first KubeCon. They were attending the KubeCon for the first time. So do join Women in Cloud Native Community. I also did interview with Adriana, and that's how we met. I met amazing, amazing people in this community. I'm also looking for new job opportunities, so you can connect with me if you are interested to work with me. I'm looking for cool projects. So that's my website, collection of my talks and work. Awesome.
And
thank you, everyone.
Thank you for sticking around at the end of the day.